If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You're listening to AFM radio on Astronomy.FM, around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.FM.
The pirates are coming.
Arr! Arr! It's Space Pirate Radio time here on Astronomy.FM, everyone. It is another Wednesday evening. This one happens to be October the 25th, 2017, 9 o'clock in the evening for those of us here in the eastern portion of North America. And it also is Universal Time, 1 o'clock in the morning on Thursday morning, October the 26th, 2017. So, yes, that means you are now listening to us live, and, of course, some of you will be listening to us at the repeat, which we do every 4 hours for the next 24 hours. And for those of you listening to the live portion, don't forget that we have our chat room wide open for you to come on over and join us right now at Astronomy.FM, and you'll find out where it says Radio Chat. Just click on that. That'll get you to the login page. Type in a name, and you'll be here. You can ask us questions if you want to, and we will answer your questions on air as best as we can. And you're also considered part of the crew once you join us here in the chat room. So let's say hi to everybody in the crew right now. We've got me and you, of course, Twist Edge, Glenn, Richie, Plaid Joan, Plaid Mac, 819829. That's when you don't type in a name and hit enter. Doug at Northern Cross Observatory, Odd, Aquafew, and Doug's in twice. Cool. How are you doing, Dianne?
Doing all right. So, I was, of course, out in Vegas last week for work.
Mm-hmm.
So, everybody, the crew keeps asking me what I got up to. It's like, not a lot, actually, but it was a good trip.
You're a dealer?
Ha!
Blackjack?
No, I don't gamble.
No, not. You don't gamble when you're the dealer.
That's true. I do not partake in the gambling machine.
Okay. All right. Wasn't that kind of work then? Showgirl?
No, the casino is something I walked through on the way to the conference room.
Okay.
Mm-mm. I was taking classes.
Ah, okay. It was for work, but not actual
I was a little sorry. Yeah. No, well, it was for work. Correct.
Okay.
I was a little sorry to be out there at the time that they had the opposition of Uranus, because the media was hyping that up something crazy.
Really?
I read some articles. One of them mentioned, I believe, I am paraphrasing here, but it said that it would light up the sky. It's like, no, a 6 magnitude object. I don't care where you are.
Yeah.
I don't care if you're at the North Pole or the South Pole at the depth of winter. It's not going to light up the sky.
No.
It does not happen that way.
Especially in, like, downtown Vegas. Vegas lights up the sky.
Yeah.
Something in the sky in Vegas does not light up the sky.
You can do very good astronomy within a fairly short distance of Las Vegas, because 8 years ago, my husband and I were down there for the very first conference I got sent to.
Mm-hmm.
And so we had a rental car, and we brought along our 66 millimeter refractor.
Mm.
And we went out to the mountains near Vegas and positioned ourselves so that the mountains were blocking out the beam from the pyramid at the Luxor Casino.
Ooh, pyramid.
Which is one of the most obnoxious. Yes, it is a pyramid. It is also an obnoxious source of light pollution because it has this light ray. So we positioned ourselves so you could not see the light ray or any of the other lights from the strip. And we were able to take in some sights that you cannot see from our normal latitude here in southeast Michigan, like the galaxy Centaurus A.
Oh, nice.
And Omega Centauri.
And the planet Uranus.
Well, not in 2009, but had I had access to a car and my binoculars, neither of which I had because I was traveling light, believe me, I would have been out there looking for it. Instead, I got to read the reports of some of my colleagues from the Astronomy Club here in Michigan who did see it, and I'm jealous. But yeah, I missed opposition.
It's not an event you have to worry about missing, really.
No, it's not like an opposition of Mars.
It's not actually that much closer to the Earth that it makes a difference.
It's very far away.
Yeah.
There is a window of time.
2 billion miles or something like that?
Yeah, there is a window of time, like now, where it's easier possible at any rate, to see Uranus naked eye, which is one of my bucket list items.
Mm-hmm.
But it's just not like opposition of Mars, where you have a small window to catch something when it's wonderful and you can see this amazing detail, and then the rest of the time it's honestly pretty mediocre.
Yeah.
Mars is a lot closer to us.
Yeah, it had been in the past, pretty much like in the band of the Milky Way. Yeah. Not a good object, 6 magnitude, quote unquote, star in the band of the Milky Way is not a good thing to go look for. Sorry, cough coming up here. Because there are a lot of 6 magnitude stars along the band of the Milky Way.
Right.
So you really need it when it's kind of...
to put it mildly.
Yeah, need it when it's a bit farther away. And, away from some brighter... Well, it can be okay near some brighter stars, but it's got to be away from a bunch of other 6 magnitude stars. It can't be somewhere near a cluster, for instance. So, I'm trying to think of where it's actually at here. Let's see. Constellation is that... It's in Pisces.
Yeah.
Which has a fair amount of 6 magnitude stars and some brighter ones. And yeah, it's kind of a bit of a star-rich region, but not too bad. Kind of near... Too bad. Yeah. Pisces. Whatever they are. I can't remember what the old... Torcularis septentrionalis is the name of the star that it's kind of close to. That helps you any? Oh, well. Kind of between Aldebaran and Fomalhaut. That's about the best you could do. But not too bad to look at. Let's see. Where were we talking about? Oh, the opposition.
What I got up to in Vegas, or rather what I didn't get up to in Vegas
that's
week.
Right. Did you get to some of there used to be astronomy stores in Vegas. Is there still?
I did not have a car. I was in class during the bulk of the daylight hours, so I did not get up to very much.
Okay.
As I told the crew in the chat room, I went to a few good restaurants, and I went to the Atomic Testing Museum, and that was about it.
Okay. Quick trip just for work mostly.
Pretty much. In and out.
Yep. Oh, well, at least you had some decent stuff to do.
Yeah, I was, if you're interested in aliens, the Atomic Testing Museum is a pretty cool place. So it is not a tourist trap. It is a government museum that has covers the sweep of atomic testing, because Nevada was, of course, a critical site. Before Vegas was known for casinos, mm-hmm. It was known to be a place where you could see mushroom clouds.
Mm-hmm.
And so it's a very sobering, moving museum, but the gift shop is a little more lighthearted. There's a lot of Roswell, Area 51 kind of alien stuff.
Or somebody was asking any skydiving Elvises.
Yeah, Elvis, people made jokes about that at the conference, but honestly, the Elvis presence isn't so much I didn't really notice it. I mean, the hotel where he married his wife Priscilla got imploded many years ago. Mm-hmm. I think you have to go looking for Elvis in Vegas rather than stumbling across him.
Okay. I guess we should do some astronomy stuff.
Sure. How's the sun doing? Because it was not doing much last I talked to you.
Yeah, for about 2 weeks we didn't have anything, and right now it has two clean your monitor spots on it, because they're smaller than the Earth. One is active region 2685, the other one 2686. Just two small spots, something that will basically help you focus your telescope on the sun, but that's about it as far as sunspots go. There's been a little bit of solar activity, some G1 magnetic storms coming off the sun, a little bit of coronal hole, so there's been a little bit of action, and some of the active regions are a bit active. So at least visibly it doesn't look real good, but in other wavelengths, like extreme ultraviolet, it does look like there's a bit of activity. And if you live pretty much close to the poles, you've got a bit of a chance of seeing some auroral activity too right now. So something to see out there, and a little bit of activity with the sun, but not much. We'll see if it gets better or worse. But so far, 2 weeks without spots, that was not good. How about a little bit of the planets and the moon? So let's see. Well, yesterday, if if you happen to notice that the moon, Saturn was just about 3 degrees south of the moon yesterday. The moon tonight is at apogee, which means it's at its farthest point in its orbit around the Earth. Tomorrow, Jupiter will be in conjunction with the sun. Which I looked at my star chart. Yeah, it's pretty much not directly behind the sun, but in alignment with the sun. So Jupiter's a non-observing object right now.
Yeah.
Friday, first quarter. And then coming up Sunday, Pallas at opposition. I'll have to look up where that one's actually at. So that's one of the major asteroids, by the way.
Yes, one of the original 4.
Mm-hmm. Is it 2 for Pallas?
I believe 2? So, yeah.
2 Pallas?
Vesta's 4.
Vesta's
I believe
4?
It's Ceres, Pallas, Juno, Vesta.
Okay. And next Monday, Neptune will be 0.9 degrees north of the moon, and there will be an occultation somewhere in the world. I didn't look up exactly where, though, but somewhere out there. 0.9, yeah, probably not very favorable for a moon occultation of an object. But Neptune is just northeast of Fomalhaut currently, so
nice.
Definitely visible in evening skies. Pretty easy to see. And it's got just a touch of Saturn out there. Of course, the moon's coming around. Moon's a bit of a crescent almost at first quarter, another couple days or so. So still a little bit of observing out there. Venus and Mars are in the early morning skies, kind of in the sun's glare. But Mars will start to come out from the side of the sun and be more and more visible as time goes by. We should be coming up on another opposition in about 9 months, a year, something like that.
Yeah, we are, actually. So the group that I am currently the president of, one of the groups, Great Lakes Association of Astronomy Clubs, we were discussing whether or not we would move our autumn event, our annual event, Astronomy at the Beach, to try to chase the Mars opposition, which we decided not to do for a couple of reasons, even though we hope that there will be a lot of interest from the public. For instance, the year that 2003, the year of the modern internet era where there was a really good opposition of Mars, 10,000 people showed up at Astronomy at the Beach to look at Mars that year. We've never seen anything like that since. But we figured that this was not such a good bet for a huge public event at our latitude because we cater to families.
Yeah.
In June or July, it gets dark very late. So people can come and see Mars, but they won't see anything else.
Yeah.
And if it's in the summertime, the public schools, which are a major supporter of ours, don't really have time to get the word out. They're on
nighttime
holiday.
is so late. Yep.
Nighttime's late. School's not in session. So it's really not favorable for our conditions for a really successful public astronomy event. So we will be showing people a okay, but not super close Mars in mid-September instead.
Depends on how you advertise it. It's like
indeed.
It's the closest in 712 days.
Yeah.
Or you could break that down into seconds. It's the closest in 38,000 seconds.
Well, that's the other thing is that we've had that meme, that ridiculous, Mars, size of the full moon. It's been circulating for next year. It'll have been in circulation for 15 years. That's a really long time to have some fake news, basically, going around. And I think at a certain point, people just kind of tune it out. How many times can you get faked out a year?
Well, for some people, quite a bit.
Well, yeah, but how many times are you going to get in a car and go drive to an event based on the fact that you got faked out again?
That's right.
Probably not too many times.
Yeah. Well, we'll hope for the best. It's all about the weather, too, and everything else. So.
Totally. It is very much about the weather.
Speaking of weather, this Saturday is it International Observe the Moon Night?
I believe so, yes.
Yeah. As not just national, but international?
International, correct. It is.
So it's a little bit past first quarter, which makes it, prime viewing for
Lovely
the early part of the evening. Yep.
Yes.
You get a bit of a Terminator there, so you get the most detail on the moon. It'll be out in the early part of the evening, so kind of good for a little bit of everything for observing the moon. Do you know why they put this observe the moon?
I do not, actually.
I don't either. It's like, well, you either look at the moon or you don't look at the moon.
I would guess it would be a counterpoint to Astronomy Day, but certainly observing the moon is a great way to get the general public interested, because if you've never looked at the moon through a telescope or a really good pair of binoculars before, it's pretty amazing.
Mm-hmm.
If you haven't looked at the moon in a while, it's amazing. You might want to check it out.
There you go. Might be kind of like Swedish Day, it's just an extra holiday thrown in there. So,
well, it's also an easy one. I mean, the moon, the skies can be kind of lousy. You can be not too comfortable with your skill at a telescope. For instance, I know the sky quite well, but my physical skill manipulating a piece of optical equipment is well below my husband's. Mm-hmm. I'm clumsy. He's really good. He's an engineer. I'm not. That might have something to do with it. But so I can stay on the moon. I can find the moon. I can show the public the moon. No problem. Do not expect me to find the Dumbbell Nebula in really lousy skies. I know where it is, but
without a locating computer.
Locating it in lousy suburban skies is a different question altogether.
Mm-hmm. Well, see what happens that night. And I know if they still remember it, everybody's going to want to know where the hole in the lava tube is on the moon.
Mm-hmm.
You know about that? Yes.
No, I haven't. I saw a headline on my Alexa, which is my virtual assistant that lives in my bathroom.
Okay.
Tell me about it.
Let me see if I can find.
I'll ask you instead of asking Alexa.
The picture from that. Yes, there was a recently discovered opening on the moon to a lava tube.
Cool.
And I don't remember what portion of the moon it was in. I can't find that article or picture. It should be here. Where's that little dot? I don't see it. All right, we'll see if we can find it. Yeah, there was recently discovered. I think they first were looking using like radar and penetrating the moon surface and looking for different densities and stuff like that. So they kind of found a lava tube, and then they found where there was actually an opening to the lava tube. So everybody's thinking, ooh, instant shelter. Got a possibility. Well, the lava tube's actually pretty long. It's like 30 miles or something like that. But if you can just kind of, walk down into it and close off the ends, get some instant shelter that way, shielded from cosmic radiation without having to dig something out, a little bit more efficient that way. So it's got some potential. Maybe somebody in our chat room will throw that article up there for us. A picture of that lava tube opening on the moon would be great. So that was the big news thing lately.
Well, I got another piece of news that I thought was really cool.
Okay.
We've got an interstellar comet.
Yes.
So this was discovered using the Pan-STARRS telescope on Haleakala, the wonderful mountain in Maui. And it has a hyperbolic orbit that doesn't appear to be bound to the sun. So the suggestion is, the preliminary finding, this sucker escaped another star.
Ooh.
Which might make it the first case of an interstellar comet. So that is pretty darn cool.
And the way they usually could detect that is by the shape of its orbit as it comes in from outside the solar system, how it's going to get close to the sun, how close it is, and how it comes out from behind the sun and goes back out into space. So there's basically the shapes of a cone. You got elliptical. So that means a comet, let's say, would be in orbit around the sun. It would circle out beyond the sun, let's say beyond the orbit of Mars, turn back on itself and go back around, so making an elliptical shape. The next one would be a parabolic shape, where it comes from a point that is like you can't. Well, it would be like kind of infinitely far out, goes around the sun, and goes back out into space, basically along the same path. That'd be a parabolic shape. The hyperbolic shape would be one that comes from well beyond the stars. It goes around the sun and goes off in a completely different angle from a completely different direction. Maybe more of a hyperbolic curve to it. So if you look up your basic cone-shaped curves, you'll find it there. So this one means that, yes, it came from far away, just sort of kind of glanced by the sun and then took off in another direction.
Yeah, so previously there was a comet that was suspected that it might have an interstellar origin, but apparently the orbit got warped by Jupiter into a hyperbolic orbit as it left the solar system. So it came in on a normal trajectory.
Okay.
This is it was discovered back in 1980.
Normal being what, though? Within our solar system?
Within our solar system, yes.
Okay, maybe like the Oort cloud type of thing?
Yeah, exactly. And it passed close enough to Jupiter, 0.23 AU, so 0.23 times the distance of the Earth to the Sun, that Jupiter gave it a boost in speed that warped it. And it exited, appearing to be an interstellar object, which maybe it did indeed go out there. But that's not where it came from. Whereas this one may indeed have come from some other star. So that is actually pretty darn cool.
Oh, that's what they're saying about this one? It was like it was completely a hyperbolic orbit.
He might have stole it from something else.
So maybe it came from another solar system, went into our solar system, and our solar system threw it into a different solar system.
You can do a lot of adventuring in 4.5 billion years.
Yeah, so somebody might think that we actually sent the comet to them. Well, we didn't. We just kind of like ducked it and let it go on to another solar system. And do you know when it's supposed to get closest to the Earth?
I believe it already passed. One second. I got my article already.
And then
my browser.
And then how about its perihelion, which is its closest point to the sun?
It got within 23 million miles of the sun back on September 9th.
All right, that's Mercury distance or so.
At its perihelion, it was a 20th magnitude object for us. So we are talking, you would need a good telescope on top of a mountain to go see it.
Yeah, so this is not a majorly big comet then.
No, so its closest approach was actually last week on the 14th.
Okay.
And it was
to us or to the sun?
Yes, to us.
Okay.
15 million miles.
Okay.
Not anything to get excited about.
Not at all.
Other than the trajectory. The trajectory is why we care.
So this was a small one.
Yep.
And that was it. Mostly just a small one that came from out there, flew by, and left.
Yep.
So definitely nothing good about it. Nothing
more
than that interesting.
Well, left for parts unknown is what the interesting thing is.
All right, let's see. Oh, we do have a picture of that, what you call it, the hole in the lava tube.
Oh, nice, the lava tube, yeah.
Yep.
Let's see it.
All right, let's see. Oh, I want to put this up, this link for people just to kind of, I haven't put it up in a while. It's called solarsystemscope.com, and kind of a little interactive of the solar system, so you kind of, let me put it in a chat room here. You can move it around. Wait, where you go? Wrong way. There you go. So what you do is you can actually click on it. It's a kind of a computer model of the solar system, and you can move it around. You can move it up and down, and you can look at the sun from the solar system from edge on. You can rotate it around, so basically you can look from the Earth towards the sun and see where the planets are. And right now, we can. This you can see the Earth is Jupiter's right behind the sun from the Earth's position. You can look at it from the North Pole. You can look at it from the South Pole. So you can kind of flip this thing all around and get a view of our solar system from different vantage points. It even has the newer outer dwarf dwarf planets on it. Eris, Hume, Mickey, Make. Yes, it even has those orbits on, so you can see how they're extremely tilted and elongated to the rest of the solar system. And Pluto more of an inner planet. No, it's got Pluto listed as a dwarf planet also. So go click on it and flip it around. It's kind of nice to see if there's any. I use it to see if there's any alignments of planets and stuff like that, just for fun. Get a different view of the solar system from different vantage points. It's fun. You can zoom in and zoom out. Yep, check that out. Let's double check our. Let's see, what was I going to double check? I don't know. Oh well. I guess I'm not going to double check something. Whatever I was going to double check, I lost it.
Well, I got a little story with a catchy headline. It's called Kronos, the Eater of Planets.
Kronos,
the Eater of Planets, the Devourer of Planets. So that sounds like something out of a comic book.
Okay.
Or perhaps you might remember that in Greek myth, Kronos, an analog to the Roman god Saturn, similar position but not really the same thing. But he devoured his children, including Jupiter, or rather, including Zeus, Hera, Poseidon, etc. So we've got a star in our solar system, about 350 light years away, that over the course of its 4 billion years of existence has devoured up to 15 of its own planets.
Well,
yeah. Not a good place to be in its solar system.
Mm-hmm. Now, did it do it by expanding, or did it do by just they spiraled in, or?
It's not known. There's some theories. So Kronos has a companion star, a Krios, which has not eaten any planets. And the thought is perhaps that Kronos and Krios as a system passed too close to another star, hypothetical unknown star. And that stretched out the orbits of the outermost planets of Kronos, which caused them to do a sort of a demolition derby thing through its inner solar system, sending the inner planets into a death spiral. But the problem is that, this didn't happen in Krios. So you've got a two-star system where one just got wrecked, the other one didn't. But when you take into account that they're about 10,000 years they're far enough apart that it takes 10,000 years for Kronos and Krios to orbit one another.
Mm-hmm.
It's possible.
Yep.
It's possible that one could get completely destroyed and the other one would be pretty much fine.
Mm-hmm. Cool. Oh, let's see what we got up in space lately. I got to say goodbye to former astronaut Paul Weitz.
Yes.
He's recently passed away.
Mm-hmm. Veteran of Skylab.
Yep.
And as few people as went to the moon, Skylab had a pretty small number of people can claim to have been on Skylab.
Mm-hmm.
So he was also a shuttle astronaut. So he was did missions with Challenger.
Mm.
So he was a member of the Skylab 2 crew, it was Skylab 2, but that was the first manned Skylab mission. And he was the commander of the maiden voyage of Challenger. So 2 quite historic flights.
Mm-hmm.
One of his crewmates on Skylab 2, Pete Conrad, was the third man on the moon, so a veteran of Apollo 12. And the third member of the crew was Joseph Kerwin. And they were a very efficient crew. They logged 672 hours and 49 minutes in Skylab. Yeah. And that at the time was the world record.
Nice.
Had Apollo 20 happened, he was a potential command module pilot.
Ooh.
So he might have had the Nixon administration not pulled the plug on Apollo, he might have gone to the moon, though not landed on the moon. He would have been in orbit.
Mm-hmm.
So, quite a fascinating career, and yet another loss of an age of space exploration that we can't currently reproduce.
Yep. He was 85 when he passed away.
Yes.
I think he did an appearance at an Arizona convention.
Oh, nice.
Yeah,
I did not have the opportunity to meet him. So.
Remember somebody posting that? I think it was Prenvera Heisen from Kosovo that posted she met him.
Nice.
And then that was just like 4 or 5 months ago, something like that. Maybe a little longer. Let's do a little station identification. You are listening to Space Pirate Radio here on Astronomy.FM. It is another Wednesday evening. This one happens to be October the 25th, 2017 at half past the hour, also known as Universal Time. That would be put it at 1:30 in the evening. Sorry, 1:30 in the morning, October the 26th, 2017. So we still have another half hour's worth of program to go on. I hope you're listening in to us. If you're listening in live, come on over and join us in our Astronomy.FM chat room. Just go to the homepage, Astronomy.FM, and you'll see where it says Radio Chat. Click on that, and you'll be here. Don't forget, we've got more programming coming up after Space Pirate Radio. Usually, the usual ones are Astronomy Ireland. We've got Planetary Radio, Naked Astronomers, Naked Scientists, all coming up after after Space Pirate Radio. So keep tuned in. And of course, you might just catch us on the repeat. We repeat all these programs every 4 hours for the next 24 hours. But this is the best time to be here in the chat room when we have our crew here live. All right, let's see. Let's go with what's happening with the space station. On November the 11th, we've got a launch of an ATK cargo resupply mission to the International Space Station. That will be November the 11th on a Saturday, 7:30 local Eastern Daylight Time for the East Coast of North America.
Nice. Will it be possible to see that ATK craft?
To see it, in space?
Yeah.
I have no idea. I'd have to look that up. I've been meaning to do this. I want to see how from launch time to when it actually connects, to see if it would be visible from North America and visible at nighttime. So if they go up and they connect right away, might not be able to see it. But if they go and spend, it'd have to be a good 12 hours in space before they connect, then it might be possible. If that happens over North America, sometimes it doesn't happen over North America because the angle of the orbit of the space station, we just might not be in the spot where we can actually see it flying over us. I have to do some checking on that and see if it's possible. I looked at some of them, and some of the disconnects, for instance, were really fast, and again, they were happening during our daytime, and not even if it was over our area, wouldn't have been visible anyways. I have to do some more checking. I don't think any of these are even visible from North America.
Now, this is one launching at Vandenberg?
Let's see. I don't know where didn't say where it's launching from.
Okay.
Let me go I'll click on the link. Which again
there's an ATK launching at Vandenberg at the end of the month.
Is there? Oh, I didn't see that one listed. Okay. Goes to a bunch of articles. I'd have to search for it and see. No,
never mind. If I didn't have a day job, I'd go around following rocket launches just for the thrill of it.
I know. That was what we sort of used to do as an astronomy club back in the 70s. Whenever there was going to be a major launch, like a Saturn V, we'd have several people, like a dozen or 24 people from the astronomy club here in Michigan, go all the way down to Florida to watch some of those launches, kind of make a vacation trip out of it.
That would be amazing. Certainly, if we ever get the heavy lift rockets back up and running, I would definitely try to organize something to see that.
Yep. I've never done that. I've seen all sorts of people have done that. Never watched the shuttle launch from on-site.
Shuttle launch was amazing, but a Saturn V would have been amazing too, and I missed that. I was not alive for any of that.
The only launches I've seen are some smaller rockets, and from usually like at least 50 miles away, if not more.
Ah, okay.
So I have seen, I think, one for sure. One, I think I saw the smoke trail from after it launched. I don't think I actually saw it launch, and that was it. a vacation in Florida. I always wanted to try to get down. There was always delays in launches. For the space shuttle especially, the big Saturn V's were pretty much on time within a day or two. Some people were able to, I've heard stories of people going down there, and they delayed it for a few days, and they had to go home, and it was launching on the day that they were going home, so they were technically on the plane when it was launching. And I don't know if they got to see it from the plane or missed it altogether.
It was pretty tense when we went down to see the final shuttle launch because, of course, A, you know that there's not going to be a second chance. And B, the weather was pretty terrible.
Yeah.
So it was dicey, but thankfully she took off.
Mm-hmm. There were two places you could see the launch. If you got a pass ahead of time, you could just basically contact NASA and got a pass to get on the grounds. I think you were still at least 3 to 6 miles away. I can't remember. I think
they had a 3-mile point for the press.
Yes,
and a 6-mile was as far as the general public who got tickets in the lottery could get.
Yes.
At least at the end of the program when I attended. And then they had another point that was at the Astronaut Hall of Fame, which is across the causeway.
Yes.
From the rest of the Kennedy Space Center.
And
that's about 11 miles?
Yeah, so I was going to say 12 miles maybe, something like that.
I think it was 11, but it was fine. I mean, we could see it. We had a telescope, so we could zoom in on the shuttle on its launch pad. And, of course, the launch itself was amazing. So.
Mm-hmm. And even though, obviously, amateur astronomers had brought their pretty good telescopes there, so they were able to zoom in across the waterway to be able to see it close up, and video cameras and still cameras, and I think that was after film movie cameras. I think it was mostly like VHS type of cameras that if they did any video of, mostly stills though, slide film stuff like 35 millimeter stuff.
Yeah, and of course you could see it from the mainland. From Titusville, which is the nearest city, or from Cocoa Beach. I mean, my father saw a shuttle launch in the late 90s or maybe early 2000s. Mm-hmm. I believe it was Columbia that he saw take off.
Okay.
So.
Yeah, from far away, it's actually not that hard. Kind of like, when you see a really high-flying passenger jet.
Yes.
With a contrail, and you can catch it in the sun glare where you can barely see the jet. It's kind of a little bit of a white glare. That's kind of what it's equal to seeing a rocket launch from 50 miles away or so. Plus a little bright flame coming off the bottom was
right.
More than what a jet does.
Right. No, I really hope we get the heavy launch rockets up and going because I want to see that. I want to see something equivalent to the Saturn V very badly.
Mm-hmm. I thought they just had an engine test recently at NASA, if I'm not mistaken. Yeah,
they're working on it.
It was a Mars mission.
Yes.
Engine test that they just did.
Oh yeah, you're going to need a phenomenal rocket to get people to Mars.
Mm-hmm. Some interesting views of the planet Mars, basically, from Mars Reconnaissance Orbiter of the Hellas Planitia region. We put that link into our chat room here.
Yeah, we had a couple of stories about Mars hit recently.
Yeah, it's been some.
Gives me idea. It's got a magnetic tail. That's cool too.
Yes, it does. But, it's not the same kind as on the Earth. So it is an interaction between the sun's, the solar wind, and like on the Earth, the sun's solar wind interacts with the Earth's magnetic field, and out behind the Earth, the magnetic fields will connect and disconnect and then reconnect, and that sparks a little bit of extra energy. Mars doesn't have a magnetic field that way.
Yeah, it did have at some point in its life, but it lost it.
Yeah, I think they thought it was for the first billion years, and now it's to like 2 billion years. They think it's had a magnetic field.
Yeah.
But what it does have is magnetic material on or under its surface. So in those areas, there is a magnetic field on certain parts of Mars. And the solar wind can interact with those magnetic fields, and there can be some magnetic reconnection in the tail of Mars. That's when things go, like snapping a rubber band. It snaps back and gives a little boost of energy there. So, and the Mars, I think it was the Mars Reconnaissance Orbiter it goes around Mars, and it has a magnetometer on it, so very sensitive device that detects the field direction and intensity. So as they're going around Mars, they notice the thing does not always point in the same direction. It'll deflect one way or another way, and they could tell how much it's deflection, and they could tell by the stuff coming from the sun. So
it was Maven data, actually.
Was it Maven?
Pro.
Okay,
yeah.
All right, maybe it was Maven then. Yep. So they could tell when there were changes, and they were plotting those changes as it orbits around the planet Mars, and tell there's some differences. So it's not the same magnetic field. There's definitely some interaction with the sun and those magnetic areas on Mars itself. Not part of the core of Mars, though. Oh, anyways, squiggles on Mars. There's a picture in there's a link in our chat room now.
Yeah. Twisted tail.
Twisted tail is very interesting looking things. They say they thought these things were from what you call it?
Solar wind.
Solar tornadoes.
Yeah.
On Mars. Let's see. Screwing back way down these are dunes.
Yeah, this article did not mention tornadoes, and this was from NASA.
Or sun.
Yeah.
I mean sand, dust devils. No, I guess it wasn't. Maybe something else I was reading.
No.
Okay,
no,
so these
not
are
in this one.
All right, these are some dunes on Mars that have an unusual semi-lined up squiggle patterns in the. And there's also another, if you just go below that article, the same thing, some interesting images of some sedimentary deposits in instances inside the giant canyons of Mars. They've been kind of puzzling. Oh, my phone. Can you continue on and I'll get rid of that phone call?
Yeah, that's cool. I did not catch the Mars squiggle thing. I was mostly occupied with magnetic tail because that was pretty cool. So we've had some issues with the drill of our beloved rover up there. So Curiosity has had some problems and has had for some time. It's not news because the drill's been not operational back since December of 2016. But they did make an attempt to touch the drill bit to a rock last week, the 17th of October. And so they did a test, and they placed the drill bit onto a rock without the stabilizers to try to figure out, how it would function. So hopefully we'll be able to get that drill working again. Curiosity can get back to doing that aspect of science. Cool. Now, granted, we've already got way more out of Curiosity than we'd hoped because, we were broadcasting together, Marty, back when Curiosity landed. And at the time, we pointed out to people, it might not be like Spirit and Opportunity that keep going and going and going, especially Opportunity, because it's got a nuclear fuel. So it had a 2-year mission.
Yep.
And there was a possibility that just run out of fuel. Well, they were being very conservative in that prediction. So the 2-year mission wrapped up back in 2014, and Curiosity is still trucking.
Mm-hmm. And it was also not going to explore a large region. It was going to pretty much stay within
Mount Sharp. Gale Crater, Mount Sharp.
Gale Crater, which has Mount Sharp in the middle of it, yes.
Yeah. So it's nearing the top of a ridge that's been called Vera Rubin Ridge on Mount Sharp. But, it hasn't gotten far.
Yeah. But it's been a really great region to explore. It's like they've found signs of water. They found sedimentary rock, basically an area that had water, and dust would blow into the water. It'll settle down, and then another type of dust would come along and settle down the bottom. So we were getting piles and piles of layers that could only be from standing water on Mars.
It's definitely the most plausible explanation. I mean, maybe there's some other reason other than that, but realistically speaking, yeah, that's what it looks like.
Mm-hmm. And other signs of water too. Some different types of rocks that would indicate water or minerals too. So definitely was water on Mars in the past.
No, not to discount what Spirit, Opportunity, and Curiosity have all done, but in the event that we do get human scientists up there, hopefully will be able to work at a much more rapid pace at analyzing these things, because there's really nothing quite like living, thinking human critters to survey a site. So you know me, I am super skeptical about the viability of human missions to Mars. I mean, I've said many a time, yeah, right now with the technology we got, it's a one-way trip. Enjoy. But should somebody take that trip, the science will be fascinating.
Mm-hmm. It's just a matter of how long that mission will last.
Because it's taken us from December to October to get that drill working again. Even kind of, sort of.
To hit it with a rock.
Yeah, so a human scientist up there, that's going to be a lot faster results.
Yes, but once that mission is ended, if they stay there, that mission is ended.
Yeah.
There's no, resupply would certainly be a possibility too. One thing a robot doesn't need, a rover doesn't need resupply mission to keep it going. So the advantages and disadvantages, definitely takes more to keep a crew going than it does take a robot going. So just more expensive in a lot of ways. The amount of cargo you'd have to bring along for a manned mission to Mars. They definitely get more out of it, but you could also send a whole bunch of robots there too. And what if you sent?
That's been a trade-off.
Yeah, well, if you send 100 robots to Mars, well, obviously that kind of a mission is going to get a lot more done, maybe than one person. You never know. Just a matter of money, basically, in technology.
Yeah, but it's also a matter of what people want to prioritize. I mean, that's always been the thing: is people want to explore.
Yes.
People are happy to fund exploring because exploring is cool. So, about all these prospective Mars missions.
Yes.
And nowhere near 100 robotic missions sent to Mars.
Exactly.
A fraction of that.
Yes.
Ever. When you combine every country that's ever even tried.
What was the one that landed? Now I'm kind of losing track of all the Mars missions now. Which was the one that landed and was scraping away at the ice underneath it?
Phoenix. Phoenix was a fascinating mission in its day, but it was short-lived. It had the Twitter feed. That was the first time I'd ever been paying attention to one of the NASA missions on Twitter, because Phoenix tweeted out its mission and subsequently its demise. But yeah, it had one thing to do, to scrape through the topsoil, find ice. It found ice. So in that case, it was a success. But Phoenix was not a rover, and therefore it didn't have anywhere to go. You know? Scrape the ice and it was done.
But it was able to do its job at one spot quite well.
Yes, and it did the job. Mission accomplished.
Yep. So trade-offs between manned mission and robotic missions. And still the manned missions are definitely hard to do. Getting there is a lot riskier for a manned mission, so less chance of success that way with a manned mission, because it takes just that much more technology, equipment, supplies, and still haven't worked out that survivability factor yet.
Yeah, that's going to be hard.
Yep.
But it'll come. Not easy.
We've only had
enough time and enough money and enough research. Yes, it'll come.
What's there only been about 50 years of space missions?
Yeah, well, this was the 50th. This year was the 50th anniversary of Sputnik, and it was several years between. Well, of course, Sputnik was followed by Sputnik 2, which had the dog Laika, which was not a very reassuring mission as far as life in space, because Laika died shortly into the mission.
Yep.
Factor I've always been bitter about, because it was the children's books that I read in the 1980s and 90s did not mention that part. I had to grow up and get on the internet to find out what happened to Laika.
I know. It's like, no, like movies, like, no, not the dog.
60th anniversary. Sorry. Can't
Okay,
do
60.
math.
Well,
it was the
that's-
International Physical Year of 1957, which actually is kind of stunning that it was 60 years ago. It's terrifying at this point.
Mhm.
But
So we're still at the part, relatively like ancient Rome, going around the coast of the Mediterranean and Egypt and Greece and stuff like that. We're still, we're back about 3,000 years ago as far as, taking boats out in open water and doing exploration that way. So it took, up until the, another couple thousand years before we can start going around the world.
well, I like to. I mean, my other obsession is polar exploration. When you look at the sheer number of people who died looking for the Northwest Passage and the North Pole and the South Pole.
That was relatively modern times.
Absolutely. I mean, you're talking the Franklin expedition where they lost 121 people, about, not all of them at the actual, pole or in the passage, but because if you died earlier, that was 1846 through maybe possibly somebody could have hung on until around 1850. The Scott expedition, where of course the party that went to the pole and realized that the Norwegian mission had beat them to it, they that was 1912.
Yep.
So we got, yeah.
See, that was still way after circumnavigation.
Oh yeah, well, circumnavigation was a nightmare too. I mean, very few people came back from the Magellan mission alive, and Magellan certainly did not.
Exactly.
But that was back in, that was in the golden age of sailing ship exploration.
Yes, we haven't even crossed the major ocean of space yet.
No, well, didn't even. Very likely, humans did not provably get to the North Pole until well after the famous, Robert Scott mission. Which,
I'm talking about like Columbus going across the Atlantic. We haven't crossed the Atlantic to Mars yet.
Right.
We've gone like from one continent to another continent, like from Europe to Africa.
Not even that. I mean, when Carl Sagan said we had dipped our toe in the water, we've dipped our toe in the water. We are not the Phoenicians. We are not the ancient Greeks. We are dipping our toes in the waters of the Mediterranean or of the Red Sea or in a lake in the Rift Valley.
So we're still a long ways away as far as time goes to doing, peopled exploration of the solar system. Got a long ways to go. It's only been 60 years. That's hardly any time as far as compared to relative other explorations.
No, but we went so far within the first 20 years that I think it set some unrealistic expectations. I mean, when you go to no human beings experiencing sustained weightlessness to, hi, we're on the moon. It took 12 years from Sputnik to Apollo 11.
Yeah.
Then 12 years after that would be 69 to 81. You're barely getting into the shuttle era. 12 years after that, you're still in the shuttle era.
Yeah.
12 years after that, you're still in the shuttle era.
Yeah.
It's a plateau.
It's like first, time Europeans went to North America, and it wasn't until 500 years later that it was done the second time. From the year 1000-ish, when the Vikings crossed over, to Columbus 500 years later. So we're just starting out. Another 500 years, maybe we'll get to Mars. You never know. It might be that long.
Really depends.
Yep. Speaking of sailing the oceans and the sea, here's an interesting little article about an astrolabe. Was it recently discovered? I think recently discovered. Let me put it in here. An astrolabe, which is basically a disk that measures altitude. So you can, for ancient sailors, to measure the altitude of the sun and give you an idea of your latitude. Let's see, this one was believed to date between like 1495 and 1500. Recently discovered in the Indian Ocean in it's thought to be lost in 1503.
That's cool.
Mm-hmm. Well, kind of ties in a little bit of ancient navigation tools recently found.
Ooh, okay. So it's from part of a fleet led by the Portuguese explorer Vasco da Gama.
Mm-hmm.
So yes, and he was the first European to sail directly from Europe to India.
Mm-hmm.
So that is one of those milestones of the age, like you were talking about.
Yep. Was that going around Africa, I take it?
Yeah.
Okay.
Cape Horn.
Mm-hmm.
Yeah. So very cool. That is very cool.
Yeah, we got about 4 more minutes to go. Here's one I wanted to put up. This one I was looking for before and didn't have time for it. Seeing the far side of the Milky Way galaxy.
Oh.
Here it comes. There we go. Right there. All right. So how do you see the far side of the galaxy? Of our own Milky Way galaxy. We can't see a top view. So we don't directly see the spiral shape of our galaxies. There's ways of inferring it. Same thing with the core. We can't quite see what the center of the galaxy looks like. We can kind of infer it because we're inside of it. So it'd be kind of like, looking through a foggy city and trying to see the opposite side of the city, where you have to look through fog and through buildings and all that stuff too. So there was a team that came up a way with looking at some of the things that are on the far side of the galaxy. Now, optical light can't get through it, but radio waves can. So using the very long baseline array, they were looking for something called a maser, kind of like a laser, but it's a little bit different in astronomy too. Everybody's quite familiar with the laser beam and stuff like that. Well, basically, they're able to spot a star-forming region on the far side of the Milky Way galaxy, looking at molecular water, I believe it is. Oh. And that's energized. Okay. It's actually energized, and they were when it gets energized, it kind of it's like looking at a spectrum, a bright line in a spectrum.
Okay.
Well, they could do the same thing with radio waves in water, clouds of water on the far side of the galaxy, so they can look at a bright spectral line of water, and the radio waves will penetrate through the material that's in front of it and allow us to see it, and they can kind of figure out how far away it is, and we're able to figure out that, yep, it's on the opposite side of our Milky Way galaxy. They also did that with parallaxing. Mm-hmm. So by using the Earth's orbit, you can separate the baseline. They use telescopes from all over the world, and it's all a matter of getting better equipment and getting it tweaked in, more sensitive equipment, so they're able to detect, not just see it, but get the parallax on it to be able to determine how far away it actually is. So they're starting to map a little bit better the far side of the Milky Way galaxy. So it's kind of like, early explorers mapping North America from the coast. Indeed.
Yeah, how do you draw a map when you're there? Okay, well, we have reached the far side of our show.
We have indeed, yes. About time for us to head on out of here. Appreciate everybody listening in tonight. Don't forget, we'll repeat this program every 4 hours for the next 24 hours with our regular programming of Astronomy Ireland and what else we got? Planetary Radio, Naked Astronomy, Naked Astronomers. And, of course, want to thank everybody that's been in our chat room tonight. Really appreciate you joining us and participating. And we'll be back at it again.
Next week.
Next week, indeed. Oh, any parting shots?
No, other than check out the new Lego figures of Women of Space featuring Margaret Hamilton, Mae Jemisin's Sally Ride, and great Nancy Grace Roman.
Night all.
Clear skies, y'all.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM radio.
AFM.